In this exercise, we're going to talk about two of the measures of spread, or measures of dispersion. One of which is the sample variance, denoted on this slide here. It is the letter s raised to the second power, or s squared. There are two formulas that we can use for calculating s squared. Now, typically I use the first of these two when dealing with a small amount of data that's easy to calculate, and I look at the other one if I've got a large amount of data that has more rigorous calculations. So I've set up an example with just a few data points, and I'm going to use the first equation here. Now, just a review of what the notation means and how to actually use this formula. It is this big E, or it's actually the capital sigma, big E looking thing, means we're going to add up each of these values. Now, our parentheses indicates that we are going to have to do whatever inside the parentheses first, and then we raise it to the exponent. So for each data point x, we're going to subtract it from x bar, and if you recall, x bar is the sample mean. And we're going to take each value and square that, and then add all of those up. At the end of all that, we're going to take and divide whatever that total number is by n, which is the total number of data points, minus 1. This is known as degrees of freedom. So this is the data set that we're going to use. It's very small, and it's going to be an easily calculable mean that's going to be easy to use in our actual formula. So the mean comes out to be 5. So x bar is, as you recall, adding up each of the different data points and dividing by n the total amount. So these add up to 25, and the number is 5, so the mean comes out to be 5. We will use this for each one of the data set points. Alright, I've set up a chart here. First, I'm going to take all of the values of x and list them. The order of this doesn't matter. I would just assume that I typically just put them in whatever order is given, therefore there's little confusion. If you want to sort them ascending, you certainly can for this, but there's really no need. Now, we need to take each value of x and subtract it by its mean. Remember, the mean is going to be 5 for each one, so our values turn out to be -1, -2, 4, 1, and -2. And we have two values of 3, which is why we have two -2's. The next step is to square the values that we've calculated in the middle column. So basically we've taken this and raised it to the second power. This symbol here looks like a little hat. It's called a caret, and that means you're going to raise whatever it is to the exponent. Please note that I have used parentheses to do so. If I had just written -1 raised to the second power without the parentheses, that answer would come out to be -1, and that is not what we want, because it ignores the first minus. So just be careful of that. Also note that since we're raising everything to the second power, it is an even number. These numbers must be non-negative. They can be 0, but they cannot be negative. Now, our last step is to add up all of these numbers here, which total up to 26, and divide by 1 less than the total number of data points. So we're going to divide by 4. When we do that division, we have 6.5 or 6.5. That is our sample variance, s squared. The sample standard deviation, as I mentioned, is simply the square root of the variance. That is the relationship they will always have. So if you have one or the other, you can easily calculate the unknown one that you have. So in this case, we're looking for s. We know s squared. We'll take the square root to find it. So for our data set here, we know that the variance is 6.5. So to find the sample standard deviation, we'll take the square root of 6.5, and that comes out to 2.55. You can use your calculator to do that. That's not something that you can do in your head typically. Alright, here's an exercise left for you. You've got a data set a little bit longer, but the mean will come out to be a nice even number, and you can work on that using the similar charts that I've used.